All right, let's get started. Welcome, everyone. We are here to talk about using Istio to manage multi-tenant machine learning workloads. My name is Wencheng. Limin is my colleague. We are both software engineers working at Google. We are working on Istio. More specifically, we are leading the Istio security development. How many of you have heard about Istio? Great, wonderful. What about Kubeflow? Excellent. Let me start with a little bit background about Istio, and then we'll talk about Kubeflow as a case study for machine learning pipeline. So Istio is an open service platform to manage service interactions across container and VM-based workloads. There are three main challenges on service communications: monitoring, connectivity, and security. And Istio solves all three problems for you. First, Istio provides you uniform visibility into your service communications. You get latency, request patterns, error rates, all sorts of telemetries you want to know. Second is operational agility, which is mostly about traffic management. So Istio provides you advanced load balancing, traffic shifting, traffic splitting, circuit breaking to help you manage your traffic easily. And the last is to provide the security you needed to secure your service communication, and plus declarative policy, which you can easily describe your intent. Like you can easily turn on mutual TLS to enable data in transit encryption, plus authentication, authorization, and audit to protect your service. Let's take a look at an overview of Istio architecture. On the data plane, Istio auto-inject Envoy proxy to every single service instance. And this Envoy will intercept both incoming and outgoing traffic. Combined with Istio control plane, Istio provides magic to secure, connect, and manage your traffic. There are three major components on Istio control plane. First, Pilot is responsible for distribute policy to every Envoy. Getty does policy validation to make sure the policy is good to use. Mixer is the integration point to collect and report metrics to all different backends, like Prometheus, Grafana, whatever monitoring system or logging system, tracing system you like to use. Citadel is a key to manage key cert, provision key cert to every single workload, and then you can establish mutual TLS to secure the connection. Now let's talk about running machine learning workloads in a multi-tenant environment. Typically, a machine learning pipeline can be divided into three stages. Prepare data. You store the raw data in some persistent storage, like GCS bucket, Amazon S3, and then you ingest data to machine learning workloads that analyze, transform, and split data to the format can be consumed by the second stage, like feature columns. The second stage is train your models. That include select the right models, hyperparameter tuning, and model testing and model validations. After you finish the model trainings, we move to the third stage. Then you deploy your model and serve the model as prediction service. In a multi-tenant environment, each tenant may want to have its own pipeline to run their machine learning workloads. So here comes the challenge of multi-tenancy. First, on security, you want also the isolations. Each tenant may want to provide isolation on operators. So operator can only manage the workloads and resource for your own tenants. You don't want operator from another tenant to be able to touch your workload. Second is isolation of communication. You only want communications within the tenant. Workload can talk to workloads within the same tenant, not across tenants. There might be some, data you don't want to expose to other tenants. And the last one is isolation with user access. So you don't want another tenant's users to access your prediction service, to access your notebook. The second one is operational agility. So after you build new models, Istio can help you easily test and verify how good the model is. So Istio provide traffic splitting, traffic mirroring. After you verify it's a good model, then you can leverage Istio to roll out the new model safely and easily. The last one, observability. Each tenant want to have its own view of monitoring, logging, auditing, and tracing. So they can take advantage of Istio to do troubleshooting and react quickly to provide good SLO. So here is our proposed solution, which is Istio plus Kubernetes namespace. Each tenant has its own dedicated namespace. Basically, they run their workloads on their namespace. We'll talk more about how Kubernetes namespace can be leveraged to do resource and workload isolation. Then Istio auto-inject Envoy to each workload, along with the Istio control plane. The Istio provides the security, traffic management, and observability you needed to manage these machine learning workloads. So Limin is going to talk about, how this proposal works using Kubeflow as a case study.
Thank you, Wencheng. Yeah, so I'm going to do a case study on Kubeflow to show you how you can use Istio to manage multi-tenant machine learning workloads. Kubeflow is a machine learning toolkit for Kubernetes. A Kubeflow pipeline is a platform for building, deploying, and managing machine learning workflows. A typical Kubeflow pipeline includes the following steps. First, you need to create a Kubernetes cluster. Then you need to prepare the training data by deploying workloads like TensorFlow Analyze, TensorFlow Transform to analyze, clean, and pre-processing this training data. And the next step is to train your machine learning model. And you can achieve that by deploying TensorFlow training jobs. And the last step is to serve your machine learning model and by deploying TensorFlow serving jobs. So I just use TensorFlow as one example. Kubeflow supports any machine learning frameworks, and TensorFlow is just one of them. In multi-tenancy scenario, each tenant's machine learning workloads are managed within a dedicated Kubernetes namespace. For example, user Alice resource should always be deployed in a namespace called Kubeflow Alice. Kubernetes RBAC can be used to control the operator operations. For example, it can control who can deploy the machine learning workloads, who can run the machine learning workloads, and who can configure the machine learning workloads. For example, like set quota and set access control policy or set traffic policy. We can use Istio authentication and authorization feature to secure and isolate tenants' communication. Istio provides mutual TLS for transport authentication. Data is encrypted in transit. Istio provides a strong workload identity in the form of a Kubernetes service account. Each workload is assigned a cryptographically signed certificate, X59 certificate, for the identity. And Istio is responsible for key and certificate management and distribution. Istio provides end-user authentication specifically JWT authentication for any OpenID Connect provider. For example, Google, Auth0, Facebook. And Istio provides identity-based authorization to support service level and namespace level segmentation at both the HTTP and the TCP layer. And Istio support service-to-service and end-user-to-service authorization. Istio's authorization policy language is role-based access control plus condition. So it provides both good usability and flexibility. So it's flexible because you can define custom condition using Istio attributes. Both Istio authentication and authorization are enforced locally on Envoy proxy. So it has high performance. So now let's take a look at how Istio end-user authentication feature can be used to secure and isolate user access to machine learning workloads. Let's consider a scenario that an end user tries to access machine learning workloads like a serving job. The end user request arrives at Istio ingress. The ingress will forward the request to a service called the Istio auth service. If there is no end user credential attached, the auth service will redirect the user to log in with an identity provider. For example, Google login, GitHub login. If the login is successful, it will return a JWT token, which we call request context token, or RC token. RC token contains all the information about the source, for example, source IP, and also the end user credential. RC token is forwardable between the workloads, and it is a short-lived JWT token, and it's valid only inside an Istio mesh. So it has a very nice security characteristics because the token cannot be impersonated outside the mesh. So RC token is validated locally by Istio proxies running in front of the machine learning workloads. And after the token is validated, the user is authenticated to access the machine learning workload. Now the next step is authorization. Istio provides authorization feature that can be used to authorize both channel identity and end user identity. Some typical use cases include it can authorize a developer to access a Jupyter notebook. It can also authorize an end user to access a model serving job. I show an example of Istio authorization policy here. On the left side, we define a role called Alice serving role. It allows you to read the serving workload in Kubeflow Alice namespace. On the right side, it assigns the Alice credential. So the policy says if the request comes from Istio ingress and the JWT email claim is alice@foo.com, you are allowed to access a serving job in Kubeflow Alice namespace. You can use Istio to monitor machine learning workloads for each tenant. Istio allows you to plug in any monitoring backends, such as Stackdriver, Prometheus. And you can define policies to configure what metrics, what stats you would like to log. The monitoring backends like Stackdriver provide isolation between tenants. For example, you can specify the access control policy such that user Alice only sees logs and metrics in Kubeflow Alice namespace. Istio traffic management feature provides a lot of nice functionalities, such as traffic splitting, load balancing, retries, failover. For example, you can configure policies such that the front-end namespace send 95% of traffic to V1 service. And the remaining 5% of traffic is sent to V2 workloads. And you can also do traffic splitting based on the request content. For example, request header. You can say, if the request comes from an Android device, send it to a V1 workload. If the traffic comes from Apple device, send it to V2 workload. So by doing so, you can achieve some functionalities like automatic rollout to new versions, do A/B testing for different machine learning models, separation of a staging environment and a production environment, and a lot more. All this can be configured through traffic policies. And I just show a traffic policy here. There is no application changes required, and there's no traffic disruption. Okay, now I'm going to give back to the mic to Wencheng to show a demo.
Sorry, thank you. All right, so next we're going to play a short demo. It's about how Istio and Kubeflow manages multi-tenant Jupyter notebooks. So this demo is prepared by Limin, a developer for Kubeflow. Just want to acknowledge the appreciation to him for preparing the demo. That's okay, I'm going to narrate. So the first, we're going to show you that there is a centralized UI. You can try to it manages all notebooks. Sorry, it's so fast. Let me start over. So this one shows a centralized UI, and we're trying to access a notebook from different users, and we're supposed to see access denied, which is you can see here. So next step, the user Limin is going to create a workspace plus profile under his own name, and that's a step to do that. After created the YAML file, deploy it, then switch the user to your own user, and you can launch a notebook instance. Now you connect. All right, successful. Simple like that. And here are all the information, resources about Istio community, about Kubeflow communities. If you are interested in contributing to both communities, please join us, and you're more than welcome. That's all. Any questions? Do you want to give his microphone? Okay. That's all right.
Hello, thanks for sharing all this. I just want to know how Istio and Kubeflow are running in the Google's production, and what is the scale of usage? Are they all running using this, or how is this used in production?
That's a great question. So Istio is currently release 1.2. It basically means production ready. But Kubeflow is still at alpha stage. And anyone from Kubeflow team? So probably we have to wait after Kubeflow launched 1.0. Then we can show you like what's going to be the production story on Google.
So this is just in testing. All this is in testing.
Right, this is alpha mode. So feel free to try it and give us feedback.
Yeah, but the feature is already available. production ready.
Right. Any other question?
不好意思，我英文不太好啊，我想问一下。
没关系，我也。
这个 Envoy 它，因为它是一个 sidecar 嘛，对吧？然后它会做一些缓存什么之类的啊，但是它的网络性能真的会很好吗？很适合这种机器学习这种场景？我。
That's a great question. So basic question is Envoy sidecar and how good the performance is using Envoy, particularly on network functionalities.
Yeah.
So depends on your use case and depends on the performance requirement of your application. So we did some performance benchmark. So Envoy performance is actually pretty good. It's equivalent to Nginx, which is like a high performance proxy with good reputation. The latency overhead, as we tested, is about 100 microseconds. And the CV cost is at the same level. So if your applications can tolerate 100 microsecond overhead per hop, I think that's fine. But if your application is something like Cassandra, and each transaction is also at the microsecond level, then that's something you might need to consider in terms of overhead. Does that answer your question?
谢谢。
Thanks.
我还有个问题啊，
Sure.
是因为深度学习它这种还需要一些专用的加速网卡嘛？说谷歌那边它是不是有，比如说 Envoy 它去对接这些网卡什么之类的啊，智能硬件加速代理什么之类的。
That's also a good question. So question is it possible to provide hardware acceleration to improve the performance? Whether Google provides that? I think that's a generally good idea, but I don't think I'm in a position to tell about that. Any other question? All right then. Thank you all for attending this session.